Hello, and welcome to day 29 of learning ML from chatgpt. So let's get started. So in today's lesson, we're going to be recapping days 1 to 5 in preparation for our end of basically end of course assignment. So let's review day 1 to start off with. Okay, so first of all, this is just simple linear regression. So here we're generating a simple data set where we're doing rand here, but then rand n for here because we're only one for the y, and then we're just plotting it, and we can see we get this data. As you can see, we can put a line through here which will give an accurate representation. So here we split our test set at 20% test size. Then we could do model excluding regression. This would be a sequential model, but it's just like a pre-built version. Then we can do .fit and then y-predict equals model.predict. And we can calculate the MSE and R-squared score. Then we can also plot the line with the points. Okay, so this is where I did the assignment, and I made my own data, and then the line of best fit, which is this. Okay, so that's all for day 1. So now let's go on to day 2. Okay, just to recap, so linear regression is when you have a line of best fit through a bunch of data samples that have a linear relationship. Okay, so now we're scaling and one-hot encoding. So we have this data, and we have a bunch of data that's not there. So we have NaN, and we're going to do with the mean. So we can do inputter, and then we can inputter.transform. So we can basically clean the data frame, so we'll make sure age and salary are clean, so that they have no NaN values. Then we can use a min-max scaler, which converts the salary, for instance here, into a range between 0 and 1. For instance, here's 1, and there's 0. Okay, so we do that for salary, and then we can one-hot encode them. So for each city, instead of doing cities, Chicago and Los Angeles and New York, we have to split them up, and a 1 by 4. If it's New York, the 1 will be in the New York column, and the zeros will be in the rest of the columns. So this is called one-hot encoding, which the ML model needs to be more efficient. Okay, so what we do is we create a one-hot encoder model. Then we can do pan data frame encoder.fit transform, and we're doing this for the cities. Columns equals feature names out of city. So we're just doing that, and then we can concatenate the encoded cities to the data frame on the first axis. So then we're going to drop city and replace it with so here we would have city here, then city Chicago, but we just want to drop that because we've already got the other ones. Okay, so then we would drop salary if it's not necessary. This one is necessary. This is the target value, so this is the y. Okay, so we then train test split, so 20% for testing, 80% will be for training data, and then we can output the shape, and here, we can just use a model, linear regression, model.fit, model.predict, mean squared error, and R-squared score. Okay, so that's all for day 2. Let's go on to day 3. So TensorFlow. Create a constant tensor. Tensor A equals tf.constant. Okay, so this was just tensor operations. So we can add 2 tensors. I'll just do the TensorFlow because that's what we've been doing in the later lessons. And then we can do mapmul, which is matrix multiplication. And I think that's all. Okay, so we can have automatically filled with 1s, or we can just make a constant ourselves. So then on to day 4. So day 4, we're making our own data set, and we're converting that to TensorFlow tensors. So x underscore tf and y underscore tf, so tensors. Model equals character sequential, so we're making a sequential model. This is going to be linear regression because it's only got 1 layer. Memory dense layer, units 1, and input shape of 1, because this is our synthetic data. And then we're going to compile it with stochastic gradient descent, which is optimizer. Gradient descent is how we slowly change our line to have a better line of fit, and then loss is mean squared error. This punishes outliers, but not so much the correct values. model fit. So here we're just training the model, and epochs are 100. So we're going to do this 100 times, and then we're going to predict, and we're going to get the model's the model's weights and the biases. Okay, then this was me just putting all the code together. So then we can see that it does do that and puts a line through the data. So now on to day 5. So let's see. So here we're using the MNIST dataset. I think this is the logistic regression. Sorry. So evidence there, 10 units. Input shape 784 because it's is it 17 by 17? I can't remember, but square root of 784 is is the image size. So activation softmax because we're having 10 output units, and MNIST has digits 0 to 9. So we're going to reshape the dataset. Oh yeah, 28. Sorry, not 7. We're reshaping it, flattening it to 0 and 1, which is what we need for the model. And then as type float, and we're flattening these images like to a range of 0 to 1 instead of doing to 255. Okay, so we're going to reshape it. Also the X test as -1 because we're reshaping it, and then 28 by 28 as type MP float 32, and we're doing the same thing there. So then we're going to do 2 categorical Y train, convert labels to 1 hot encoding, and we're going to do the same for here. Okay, so then we compile it with stochastic gradient descent, and this time losses categorical percentage. Then we have the accuracy metric. Here we're training the model, as you can see, with 20 epochs and a batch size of 16. Okay, so then we have test loss and test accuracy. So we're using the model.evaluate function, and then here we just print a random image and show the prediction. So we can just do so this is basically the model that does it, because yeah, softmax. Okay, and then what was this? Using training with graph. Okay, this just shows our model's performance. So we want to see that line going down because we want to see our model improving after each epoch, which it does. So yeah, that's all for days 1 to 5 recap. So thank you for watching, and I'll see you in the next video. Goodbye. Be sure to check in for days 5 to 10. Goodbye.